Alright, the last little section of this lesson 5.1 is talking about a theorem that we looked at when we were in the Engaged New York, but it was embedded in so many things that several people struggled with it. And I want to make sure that we understand it better now before we go forward, because it can help us in solving a lot of things later on as we're looking at angle measures in a triangle. So the exterior angle theorem says that the measure of an exterior angle, which in this diagram is angle 1, is always going to be equal to the sum of the two non-adjacent interior angles. So in this case, angle A and angle B are non-adjacent. They're on the interior, and it says that angle 1 is going to equal the sum of those two together. So if you're looking at this, what it's doing is, in a brief proof, is saying, okay, if this angle here inside the triangle is angle 2, we know that angle 1 and angle 2 added together sum to equal 180 degrees because they're a supplementary linear pair. We also know that the measure of angle A plus the measure of angle B plus the measure of angle 2 equals 180 because they're the interior angles of a triangle. So if I take my first statement here and I use the 180 and I substitute into its place the other equation, we would have the measure of angle 1 plus the measure of angle 2 equals the measure of angle A plus the measure of angle B plus the measure of angle 2. By substitution, we know this. Then the thing we want to look at is we have angle 2 is common to both sides. So we have a property that says if the same amount is subtracted from both sides of the equation, the results are going to be equal. So if I subtract the measure of angle 2 from both sides, what results is that the measure of angle 1 equals the measure of angle A plus the measure of angle B, which is a brief proof to what our exterior angle of a triangle theorem says. And so if we understand that, we can take and use that to help us solve problems. Looking at the example that we've got right here, we've got that angle JKM right here, which is 2x plus 5, would equal the measure of angle J plus the measure of angle L. So being able to set that up and solve it, we would say that 2x minus 5 equals x plus 70. And going through to solve it, the first thing I'm going to move is my x to the left side because it's a smaller value of x, so I've zeroed it out on the right-hand side of the equation. And then at the same time, I'm going to zero out the 5 on the other side, so I'm going to add 5 here. And what I do to one side of the equation, I have to do to the other. So when you look at it, 2x minus x gives me x. 70 plus 5 gives me 75. So x is 75 degrees. So let's check and see if we're right then. So we've got x here, which says is 75 degrees. And if I add 70 and 75 together, I get that these two angles on this side are 145 degrees. If I take then and plug 75 into my equation for the exterior angle, 2 times 75 is 150. Subtract 5, and I get 145 degrees. So the exterior angle is 145 degrees, and it equals the sum of the two interior angles, which together sum to 145 degrees. So, looking at the last two problems on the page, let's show our work to find the measure of angle BCD, which in this picture is where the question mark is, so I'm going to call it x. And our theorem says that our exterior angle, which is 103 degrees, equals the two interior angles, x plus 70. So when I set up my equation and I subtract the 70 from both sides, I'm going to find out that my angle C there is 33 degrees. That's the value of x. And we're done with that. Sometimes you have variables, and so it takes a little more work. We've got to first find the value of x, and then we can find the measure of angle TVU, which is they're wanting to know what the measure of this angle right here is. So again, we're going to use the same theorem. 93 degrees equals the two angles on the inside, 6 plus 4x, plus the other angle, which is 5x minus 3. And before we can do any solving for x, we've got to combine like terms. First of all, 4x and 5x together give me 9x. And 6 minus 3 gives me a positive 3. So 93 degrees equals 9x plus 3. Now I'm going to solve for x by subtracting the 3. And 93 minus 3 gives me 90. And 90 equals 9x, so dividing by 9, I find out that x equals 10. Then I go back and I put it into this angle. So 5 times 10 is 50 minus 3 gives me 47 degrees for the measure of angle TVU. Just to be sure, I'm going to check the other one. 4 times 10 is 40, plus 6 gives me 46 degrees. And if I go to check them by summing both of them together, 46 and 47 equals 93 degrees, which is what angle RTU equals, so we know that we have the correct answer and we're done. Okay, hopefully these things has helped you remember and summarize some of the things we've been doing, and that you'll be able to use these to do well on the exercises as you practice.